You write a line of Python code. Response equals requests.get http:/api.example.com. That single line executes. You get a response. Simple, right? Underneath that one line, your code runs on a Python interpreter, which runs on an operating system, which runs on a hypervisor, which runs on a CPU, which sits on a motherboard, which lives in a server, which occupies a rack, which fills a data center, which connects to a network backbone that spans continents. And that's just your side. The API you're calling has its own identical stack of complexity. Every one of those components is an abstraction layer. Each hides the layer below it. Each provides a foundation the layer above depends on. And most of the time, you never think about any of it, because the abstractions work until they don't. Then you need to understand which layer broke, what that layer normally hides, and how problems cascade through the stack. Let's map the layers. Abstraction layers are hierarchical levels in a system where each layer provides services to the layer above while hiding its own implementation details. Each layer has a clear interface, what it provides upward, and internal complexity, how it actually works. The key characteristic: layers only communicate with adjacent layers. Your application doesn't talk directly to the CPU, it talks to the operating system, which talks to the hypervisor, which talks to the hardware. Each layer translates between the abstractions of the layer above and the reality of the layer below. This layering serves three purposes. First, it isolates complexity. Each layer can be understood independently without knowing everything about layers below it. Second, it enables substitution. You can swap implementations at one layer without affecting others, as long as the interface stays consistent. Third, it creates specialization. Different people can work on different layers with different expertise. In cloud computing, understanding layers is crucial because problems at any layer affect everything above it. A hardware failure propagates upward. A hypervisor bug impacts every VM. An OS vulnerability affects every application. The layers are interdependent, even though they're abstracted from each other. Let's walk through the stack from bottom to top, layer by layer. Layer 1, physical hardware. At the absolute bottom, silicon, circuits, electricity. CPUs process instructions. Memory stores data. Storage devices persist information. Network cards transmit packets. Power supplies and cooling systems keep everything running. This is physical reality. Everything else is built on this foundation. What it hides: physics, electronics, materials science, thermal dynamics. What it exposes: computing capability, storage capacity, network connectivity. Layer 2, firmware and BIOS. Sits between hardware and software. Initialize hardware during boot. Provides low-level control interfaces. Manages hardware configurations. You never see this layer in cloud. The provider handles it completely. What it hides: hardware initialization complexity, low-level device control. What it exposes: a bootable system ready for an operating system. Layer 3, hypervisor and virtualization. This is where cloud begins. The hypervisor creates virtual machines by abstracting physical resources. One physical server becomes multiple isolated virtual servers. This is the magic that enables multi-tenancy. What it hides: physical server hardware, resource sharing among tenants, scheduling and resource allocation. What it exposes: virtual machines that behave like dedicated servers. Layer 4, guest operating system. Inside each VM, an OS manages the virtual hardware. Linux, Windows, whatever you choose. This is the first layer you typically interact with in IaaS. You install it, configure it, patch it, manage it. What it hides: hardware drivers, memory management, process scheduling, file systems. What it exposes: a stable environment for running applications, APIs for system calls, tools for configuration. Layer 5, runtime and middleware. Above the OS, language runtimes, web servers, database engines, message queues. These are the platforms your application code runs on. In PaaS, this is where provider management starts. They handle the runtime, you bring the code. What it hides: language implementation details, server configuration, connection pooling, request handling. What it exposes: APIs for your code to interact with, frameworks that simplify development. Layer 6, application framework. Higher-level abstractions built on runtimes. These frameworks provide structure, common patterns, and pre-built functionality, so you're not building everything from scratch. What it hides: HTTP parsing, routing logic, session management, security implementations. What it exposes: high-level abstractions for building features quickly. Layer 7, application logic. The top of the stack, your actual code, your business logic, your features, your unique functionality. This is what differentiates your application from everyone else's. What it hides: nothing. This is your domain. What it exposes: functionality to users, value to the business. Every layer depends on the layer below it, providing stable, reliable abstraction. When you deploy a web application, you're trusting 6 layers of abstraction you didn't build and often can't see. Here's why understanding layers matters. Failures cascade, and the layer where problems originate determines what you can do about them. A hardware failure, layer 1, affects everything above it. If the physical server dies, your VM dies, your OS crashes, your application stops. You can't fix hardware from inside a VM. You're dependent on the provider detecting the failure, migrating your workload, or replacing hardware. A hypervisor bug, layer 3, can affect multiple VMs on the same physical host. Your OS is fine, your application is fine, but the layer they're running on is broken. You might not even know the hypervisor exists, but it's breaking your stuff. Again, provide a fix only. An OS vulnerability, layer 4, is your responsibility in IaaS. You need to patch. The layers below are fine, the layers above depend on you fixing this layer. This is where shared responsibility becomes concrete. Below layer 4 is provider territory, at layer 4 and above is yours. A runtime incompatibility, layer 5, breaks applications without breaking the OS. Your Python code worked fine, then the runtime updated to a new version that deprecated a library you depend on. Lower layers are stable, but your application layer breaks because the runtime layer changed. Understanding which layer a problem exists in tells you who can fix it, what tools can diagnose it, and how far the impact spreads. Misdiagnosing the layer wastes time chasing symptoms instead of causes. So why does understanding abstraction layers matter if most of them are hidden? First, it shapes your troubleshooting strategy. When something breaks, you need to identify which layer is failing. Is it your code, the runtime, the OS, the infrastructure? Each requires different diagnostic approaches and different expertise. Second, it determines your architectural decisions. If you need to control layer 4 and 5, you need IaaS. If you're fine delegating layer 4 to the provider, PaaS works. If you want to operate only at layer 7, SaaS is appropriate. Your requirements determine which layers you need to manage. Third, it affects your security model. Each layer has different attack surfaces and different security controls. Application layer attacks require application layer defenses. OS layer vulnerabilities need OS-level patching. You can't secure layer 7 from layer 4. Security is layer-specific. Fourth, it influences performance optimization. Bottlenecks at different layers require different solutions. Application layer slowness needs code optimization. OS layer resource contention needs configuration changes. Network layer latency needs infrastructure adjustments. You optimize where the problem actually exists. And finally, it defines your dependencies. Every layer you don't control is a dependency on someone else's implementation. The more layers you delegate, the more dependencies you have. Understanding the layers helps you understand your risk exposure. Abstraction layers are the invisible stack between your code and the hardware running it. Each layer hides complexity, provides capabilities, and creates dependencies on the layers below. In cloud computing, you typically operate somewhere in the middle of the stack. Layers below you are managed by the provider. Layers above you are your responsibility. Understanding where those boundaries are, which layers you control, and which you depend on, is fundamental to operating effectively. And remember, every simple interface is built on layers of complexity you're trusting to just work. Know your boundaries, know your dependencies. Talk soon.